is of 16-bit register, but we have the option that we can use this one as an 8-bit or 16-bit. So I can use this one as an 8-bit or 16-bit. That is, I can select the operation of this register. Now, if you just recall the functionality of register is a memory, right? And this content of this memory can be changed according to the clock pulse. So if I give an clock pulse, somehow we connect a clock pulse, and based on the clock pulse, this content can be changing. So normally it's a up counter, it will be counting upward. So we have learned to give a signal. We can connect to any of the external pin, but there is a, for this module to operate, this register is connected only given a pin. So from the datasheet, we can find out which pin is connected. So this register is inside my microcontroller, and one of the dedicated pin can be connected through this register. Let's say this pin is, I have to check, say RAX. I am telling this pin is connected to RAX pin of my microcontroller. Now we can give a clock pulse. It might not be clock. I can give any kind of signal using our traditional switch configuration. So it's a 5-volt supply is connected with a push button switch. If I connect this one to this switch, then at this point, I can control this signal, right? So here I have 5-volt. If you don't hear or if you have any problem, then let me know. So this is a 5-volt. That means this signal, if I connect in this way, then it will be always 5-volt. This terminal will get always 5-volt. That means my signal will be something. If I draw my signal, then it will be always high. That means this is 1. 1 means 5-volt. It is always connected to 1. Now, whenever I press this switch, if I select this switch, and if I connect this switch, that means these 2 points will be shorted. That means this pin will be connected to this ground, and ground is always 0. So whenever I press, this signal will go back to 0 state. So this is my 0. And if as long as this one is connected, then this one will continue to be 0. And whenever I will release this one, that means I have disconnected this one. That means it will go back to its original state, right? So it will go back to its original state. So it will continue in this way. Now, this change that is going from high to low, this is the falling edge. So this falling edge, whenever it sends this falling edge, this content of the resistor will be changing. So let's say initially it has started from 0, 0, 0, 0. It's a 8-bit resistor, so it will be 8 bit of content. So initially it may be recorded, I may store this value 0, 0 set to 0, and then whenever it find the first clock, then it contents will be changing 0, 0, 0, 0, 0, 0, 0, 1. Okay, so that means I have counted from here to here this duration, or I have counted this event, the falling edge event has been counted. So next, if I press it again, so I will have another falling edge, and that will be counted. So this one will be counted from here, and then it will continue. So that means it can count some events. So these events here is the falling edge of my switch, that falling edge of a signal. So these events, that means the pressing of the switch is related with the falling edge, and this pressing of the switch can be counted by this register as an event. So I can store this register depending on this falling edge. So this is how this register value can be changed. Okay, and how many events, how many of these kind events I can store for this one? As this one is the 8-bit register, so it can reach, by this way it can reach maximum of all the bit can be reached to 1. So this is my maximum number that it can store. So this maximum number is 255, and this minimum number is 0. So this is so from 0 to 255, that means 2 to the power 8 different sequence can be stored. That means 256 number of state can be stored. Now whenever all of these bit becomes 1, then next events, whenever next event happens, what will happen? Next event will be, I will have these bits, what happened to David?
So you can join the meeting.
Oh, what about Jess? What happens today? Okay, what happened, David?
I was waiting for like minutes, like 10 minutes. I don't know why.
Why? Why is that?
I don't know.
Okay, so that what we are talking about. So we are talking about the timer register. Okay, so don't turn off the microphone, all of you. So we are talking about the timer register, timer. So we will be learning timer today. So what do we have timer? The basic component is, main component of the timer is register. So there is one register dedicated for a timer. So the register is nothing but a memory location. So this is a register that we have inside our microcontroller. And this register, for any register, the content of the register can be changed by external clock pulse or external signal. Any kind of external signal can change the content. Normally it is up counter or the down counter, and this timer is a up counter. So this register is a up counter register. So this has a mechanism that this register can be connected to external pin of my microcontroller. I have assumed that this is my microcontroller external pin, and that has been connected with this register. So if I connect this register with this configuration of the switch, then I can have two state of the signal that can be sensed by this external pin. So what is the two state? One is it can sense directly through this resistor. If I don't push the button, then it will be always 5 volt sensed by this pin. Now that means it will be at this state, it will be high state. That means state 1. Now whenever I will press this button, then it will be, these 2 points will be connected, and that means this pin is directly connected to 0. So it will go back to 0 state. So pressing this button will create a transition from high to low. So this falling edge can be considered as an event for this register, and during this event this internal value will be incremented. So for each of these falling edge, internal value will be incremented by 1. So first one will be 1, then it will be 2. In this way it will continue to increase, and in this way whenever it is doing, it is changing the content of this register. What it does actually, it is storing how many times I have pressed this button. So it can count the number of time I am pressing this button. So this is one of the tasks of any timer. We will talk about this one. So this is sensing the falling edge and it is recording how many times we have pressed this button. And in this way, how many the number of events that I can store inside this register depends on what is the size of the register. So if I have 8-bit register, maximum number I can store is all the bit can be 1. So this is our highest value that the register can store. So this will be 255. Now from 0 to 255, it is 256 states that it can record. Now what will happen after 255 states? If I press the next button, then I will have the number will be changed to one additional number that will be the carry, and the rest of the 8-bit will become equal to 0. So these, that will be 1 bit extra, right? So I will delete this one. So this is, that was fine. So this is the 8-bit. So my register is 8-bit. Now it is 256, number 256. This 8-bit register will contain this 0. And this one will be carry. And that has no bit here to hold this carry. So that means we are going back to this state again. Okay, so from 255, we are going back to this state. And this event, whenever it is going back, this is called the rollover. So roll over. So it is rolling over to the 0 state again. So this will continue. And now whenever this rollover happens due to this external bit, this timer has one flag bit. So there will be a flag bit that will become equal to 1. So that is important. That will be important whenever we do measurement of the time. Now this 1 will set this flag. That means it has rolled over. The whole counting has finished. All the state has been finished. Okay. So this is how it can count any event. Now we are interested about the time. We are interested also this